far the mycelium of the fungi can get as far to get water to get.
Right, right. So the mycorrhizae help.
They help each other.
They help each other out. So how does a tree help the How does a tree help the
With carbohydrates, like they give them food.
Some of the sugars that it made through photosynthesis.
Yeah.
Right. Interesting. Yeah. And actually there's been work done recently to show that these mycorrhizae with the trees are helping the trees communicate with each other. So there's sort of this communication network going on in forests, which is also...
with the roots and the mycelium.
Yeah. Yeah, I'm hoping we're going to talk more about that in a different hike, actually. Sort of tree-to-tree communication. But that's pretty fascinating, too. And then, so it's just absolutely remarkable how fungi have just, I mean, they've dominated the planet, honestly. I mean, they've been so important in terms of, you know, all these ecosystems and how they've evolved and how they've developed. I mean, you know, it's not just that, but it's in terms of degradation of the material, decomposition, soil development. I mean, you name it. They're important. But humans have learned to use them too. I mean, could you name some products, some things that people might enjoy that are, you know, require fungi? Well, yeah, but I mean some things that maybe are less, not just things that we eat, not just the fungus that we eat, but we use the fungi to make them, you know?
Well, we do we dye things with fungi.
Right, but people might have heard of yeast before, and yeast is a fungus.
Yes.
And yeast is very important for the process to make certain foods that we like. Things like bread and beer, and if you like cheese, I think all three of those things require fungi, right? And if you ever get sick and require an antibiotic, well, fungi are involved in that process, and you know, many people have been, you know, their lives have been saved because of those fungi. And these are just a few examples, and there are many, 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 many more.
And for chocolate.
And chocolate. Yes. Can you imagine the world without beer, bread, cheese, and chocolate? Yeah, you can thank the kingdom fungi for these things. So anyway, so we're gonna go ahead and start off, and I'm gonna go look for some mushrooms and talk. You can go ahead and start doing some of your work. But thank you for spending some time and talking to us about these things, Claudia. I appreciate it. Claudia she can be very shy, and she doesn't like to talk on camera, but she knows a lot about fungi. She's done a lot of work on them. And so anyway, I'm going to go ahead and we're going to walk and see what we can find. Now, there are some really great books and more resources on fungi. I'll try to post some things this week on some of these things. These are just a couple. You know, there's lots of great field guides. This book right here is a really, really good one. Just a general read. It's called Magical Mushrooms, Mischief Molds, which is really great, by a friend of mine at Cornell, George Hudler. He was an extremely good instructor or teacher there. He got many awards for his courses that included fungi. But anyway, this is his book that he wrote, which is really, really good on it. But anyway, obviously, suffice it to say, fungal identification is really, really important, especially if you're going to do any kind of, any kind of collections. And that's what we're going to go talk about now. So I'm going to grab a couple things and we'll start looking. Thank you, Claudia. So we're going to go look. So let's go ahead and walk down the trail a bit. So this trail here, it actually goes in two directions. One goes along the creek that way, and what we're gonna kind of go on the one that goes a bit away from the creek first, and then we'll split back and connect up with the creek. But anyway, like I said, it kind of follows this little bit of a bottomland forest, or what we call a floodplain forest, which is a good place to find fungi. And you have to keep in mind that the fruiting bodies are often very ephemeral. They're present for a few, for a few days, and then they're gone typically. But there's some that are produced in the spring, some that are produced in the fall, some that are produced, even in the winter. It just depends on where you're at. In Florida, we have, periods of time when there's, certainly a lot more than others. But because it's been rainy lately, this is a pretty good time. But we definitely get a lot of them in the fall here. We also get a lot in the spring, right, or early summer, right at the onset of the rainy season. Anyway, right now is pretty good, although I don't know if there's been a lot of people out here picking. Sometimes, there are a lot of people in this area that like to collect fungi. In fact, there's a fungal enthusiast group on campus for students called Falafel. It's the Florida Amateur Fungal and Lichen enthusiast group, and so you can find them through social media, and they have meetings and they have speakers and things like that. So people do go out collecting and, you know, collect fungi for consumption and things like that. So anyway, let's just take a look and we'll see what we can find. So one fungus that a lot of people like to collect this time of the year for consumption is called Chanterelles. And Chanterelles are a fungus that's actually really good to eat. And here's what they look like. It's an orange fungus that looks kind of like a tubular shape. It's got gills that extend down to the what we call the stalk. But anyway, there's a lot of edible fungi, but it's very important if you ever want to collect edible fungi that you know what you're doing, because there are definitely plenty of fungi in this part of the world and really everywhere that are not edible. In fact, they are toxic, and they can, you know, they can be fatal within hours actually, and they can cause liver failure and all sorts of terrible things because of those compounds they produce. Some of these compounds we can't metabolize. They produce alkaloids and other compounds that are extremely toxic to humans. So if you don't know what you're doing and you collect the wrong fungus, you know, the results can be fatal. So you need to be very, very careful. But there are some that are very, very, very good. And in fact, you know, gourmet chefs around the world, you know, will pay big money for some of these fungi. Things like truffles and others that can be collected, you know, right here in our region. You just need to know what you're doing. But chanterelles are one of the fungi that are produced this time of the year, and we have quite a few of them, right? Easily found in our, you know, in our forests. And so this is an example. So that, of course, like I said, this is a mushroom, and the spores are produced in the gills on the underside. This is what we call a basidiomycete fungus. All mushrooms are basidiomycetes. They produce what are called Basilio spores. So this would be producing, you know, like I said, even billions of spores in one day. It's amazing, and they're airborne. And so underneath the ground in the soil, there would be a network of these filamentous, you know, thread-like growths that are, you know, the body of the fungus that are, you know, acquiring nutrients and growing on, you know, decayed matter and essentially supporting this. And that's there the rest of the year. And, you know, and you don't see that. But, you know, keep in mind, there are many, 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 many fungi in here that are growing. And to get one of these, you need to have basically two genotypes, two individuals coming together and mating. And so you don't really have, we don't have like, you know, male and female fungi, but we have different mating types. And there can be hundreds of mating types within a species, thousands of species. So it's interesting, sort of sex in fungi. You know, there can be thousands of sexes essentially coming together and individually mating to get an individual, you know, fruiting body to come to be produced. Fungi also produce asexually, and they produce spores that way, so they don't necessarily have to mate. They don't necessarily produce a big fruiting body, though. They can produce these asexual spores, which are much less apparent, and that's a completely different process that we see for that. So let's continue down the path here and see what we see. So the creek, like I said, is right over here. I'll just show that to you briefly, so you get oriented. You can see it's very pretty. Okay. They just recently had a cleanup of this creek. I know just a month or two ago. So there was a volunteer effort to get a lot of the trash cleaned out of it. So it looks pretty clean. But there's a lot of fungi that you don't necessarily see that are present. Like, for example, in this box elder, we're looking at right here, it's a box elder tree. There's a fungus called Fusarium. And actually, I was involved in naming that species. The publication just came out recently. That's associated with a beetle called an ambrosia beetle that bores into that tree and carries a fungus with it. And the ambrosia beetle farms that fungus, and so the fungus is inside that tree, and it never produces a fruiting body that you really see. So you essentially have to, you know, cut into the tree, and you have to look for it to really know it's there. And at a certain time, certain times, these ambrosia beetles, are active, and you will see sort of what looks like sawdust material coming out. And, there's other sort of evidence of the activity, but the fungus is there. And like I said, when we talked about biodiversity, there are fungi in every single piece of organic material here. Every leaf, every twig, every surface has either spores or even living, material of fungi. Mycelium is present. So keep that in mind everywhere you look. And so this world, this massive amount of biodiversity is present, of fungal biodiversity is present, and it's not all going to produce mushrooms like we just saw. Now, in terms of these decay fungi, here's an example of one here. This is called turkey tail, or false turkey tail, actually, in this case. But there's a bunch of these decay fungi that are capable of breaking down wood, and some of them occur on trees before they start to die, some on wood long after it's dead. But you can see this log laying here, and you can see all the fruiting bodies present, okay? And this is a great example of one of these decay fungi we talked about. And for a lot of these, some of them will produce gills, or some will actually produce pores on the underside. In this case, this one, it produces pores. So this is in a different group than those mushrooms that I showed you. And it has kind of a very beautiful top of the cap, which is kind of fuzzy, and you can see why it would be called turkey tail, because it looks somewhat like a turkey's tail, right? And these are actually sometimes used in art, little art projects and things. I've seen, people use these in kindergarten classes and things to make like little projects at Thanksgiving, things like that, so because you can make them look like little turkeys. But anyway, this is a really common fungus, and this one in particular has been used in medicine. There's actually a real interest in using this one for anti-cancer, for certain types of cancer in particular. I think, I'm trying to remember which one this is used for, but I know that this one's been used quite a bit recently. There's a lot of interest in this one for its anti-cancer properties. So there's a lot of that going on. This one over here is actually the one that's called false turkey tail. So you can see they're two kind of closely related ones, but very similar. So we can continue on down the path a bit, and we'll see what other mushrooms we see. Again, just like the other cut log, we've seen other cut logs like this before, but anytime you cut through a stump or a log, you'll see that it'll be decayed, and there'll be lots of molds and fungi growing on there. And here you can see, because of the chemistry of the wood, it dictates what fungi are able to grow, okay? And oftentimes, living sapwood in a tree has different chemistry than the heartwood of the tree. And the heartwood is full of antimicrobial chemicals and compounds that prevent the growth of fungi. And so you can see that very clearly here, where this cut surface, this where the sapwood was, there's lots of fungi growing in it, but you can see that heartwood is still relatively free of fungi. And so that's because of that difference in wood chemistry and the properties, because again, this has chemicals in it that are preventing the decay of that heartwood. When the tree was living, though, if it was still living, it would have had defenses here to prevent fungi from growing. So that allows the tree to essentially prevent decay overall in the tree, you see? That's why, so this type of tree would have not had a hollow in the center. It's a way to sort of prevent that from happening. Not all trees can do that. This particular tree, this particular species was able to do it. So let's continue down the path. We're going to talk about lichens later, but I mentioned that before, that lichens are actually an interaction, or a symbiotic relationship between fungi and either lichens or bacteria, or excuse me, either fungi and algal species, or fungi and certain types of bacteria, cyanobacteria. So here's some more interesting little mushrooms. Now, not all mushrooms actually are found in the soil.